In this lesson, we're going to be continuing our conversation on airflow and ducts. And as I've mentioned before, this is adapted from the Airflow and Ducts book by Leo A. Myers out of Lama Books. I do recommend that book if you want to know more about this subject and want some actual really nice examples of the different airflows and what's wrong with the duct system and how to make it right. Okay, in this lesson, we're going to be talking about air quantity and velocity. Okay, the velocity is how fast air is moving in a duct. Okay, it's calculated in feet per minute. We're going to show you how to calculate it. We're also going to calculate the quantity of air. That's measured in cubic feet per minute. Okay, so we have two different measurements here we're going to deal with. FPM is feet per minute. That's how fast air is moving. We're going to talk about cubic feet per minute. Okay, that is the quantity of air that we're moving. Now, we have to remember, a cubic foot, it's basically take a box that's 12-inch wide, 12-inch deep, and 12-inch high. It's a cube. As long as each side of that is 1 foot or 12 inches, that's a cubic foot. Now, air volume, when we deal with air volume, it's always in cubic feet per minute or CFM. Okay? A cubic foot is width times length times height. Okay? Now, one of the numbers you really need to remember is the number 400. For 1 ton of air conditioning, we have to move 400 cubic feet of air per minute across the cooling coil. So our ductwork has to be built with that in mind. So if I have a 3-ton system, I have to move 1,200 CFM of air across that cooling coil for proper air conditioning and cooling effect, because that's the design of the system. Now, we also have feet per minute. Feet per minute, as I mentioned, is the velocity of the air. It's how fast it's moving. Okay? Duct A might be delivering still. Again, we have a 12 by 12 by 12 inch duct. Okay? We're going to be delivering 1,000 CFM. Okay? If we have it in feet per minute. You notice we're saying 1,000 feet per minute out of a 12 by 12 duct. Okay, we're going to be delivering 1,000 CFM of air. That's our first step of measurement. So feet per minute makes a difference. If I increase the airflow in the same duct to 4,000 feet per minute, we're going to be delivering 400 or 4,000 CFM of air. You notice what we did between A and B. The duct size is the same. It's still 12 by 12, but we've quadrupled the airflow. So we've gone from 1,000 to 4,000 CFM, and all we did was speed up the air. Now, that sounds like an easy solution, but remember, the faster the air is moving, the more noise we're going to have. So just something to keep in mind. Okay, so now we have two different ducts here. Okay, we have A, which is a 12 by 12. We have B, which is a 24 by 24. Okay, the area of duct A is 1 square foot, because 12 by 12 is 24 divided by 144 to take it from inches to feet. And now I have 1 square foot. If I have 1 square foot with 1,000 feet per minute of air, I am going to get 1,000 CFM. You see how that works? 1 times feet per minute. Now, in slide B, my area is now 4 square foot, because I have 2 feet by 2 feet, or 24 by 24, so I have 4 square foot. Okay. Still have my 1,000 feet per minute of air. Think about this. What is going to be my cubic feet of air coming out of here? Okay? If in slide A, my airflow was 1 times 1,000 is 1,000 CFM, I now have 4 times 1,000, and you should come up with 4,000 CFM. Okay? Sort of makes sense. So the volume of air is the duct area in square feet times velocity. Have a couple different ways of talking about this equation. So to find CFM, I have area times velocity. Okay. To find area CFM, I have area times feet per minute, because that's my measure of velocity of airflow, feet per minute. Okay. CFM is also called AV, or area velocity. All it is that is a shortening of the top one. Quantity is area times velocity. Quantity is area times feet per minute. Or Q equals AV. You're going to see it labeled, all of these, sometimes on ductwork or in systems. Most often you're going to see it as CFM or Q. Now, the duct area must always be in square feet or it will not work. So we have velocity is feet per minute. Area is square feet. And CFM is cubic feet. Now you'll notice why everything has to be in feet, okay? Because we want to come up with cubic feet. So we do feet per minute as a standard measure of velocity. We have to convert our area measurement from inches if our ductwork is measured in inches, which most often it is, and then we have to take it to cubic feet. Okay. When we measure out ductwork, okay, you might be measuring one side of it in feet, one side of it inches. You always have to take it to inches, okay, or to feet eventually when you're done. So square inches divided by 144 is square feet. So area, 1 square foot is 144 inches squared. Okay. So when we take a look at this example, what is the area in square foot by a 20 by 20 inch duct? And this is a real life thing, and because this is how you're going to measure. You're not going to try to break down feet when you're in an attic measuring ductwork. You're going to measure it in the easiest thing, inches. Okay? Unless you're in a very big commercial building where you're talking about 4 foot by 4 foot ducts, which is unusual for most areas. Okay, so to find the square feet, I'm going to take the 20 by 20 divided by 144, which means I'm going to come out with 2.78 square feet of area. And again, different forms of the equation. Okay, CFM is area times velocity. Area of ductwork could be CFM divided by velocity. Let's say someone tells you, an engineer type tells you, okay, I have to deliver this many CFM to the space. I have to have it at this velocity. You got to be able to find the area needed in the ductwork. Velocity is CFM over area. Again, if you jot down these formulas, great. If you're taking this course as one of my online continuing education courses, you're going to find you'll have this cheat sheet available to you as a part of my regular formula sheets. So just to recap, CFM is the amount of air being delivered through the ductwork. Velocity is how fast the air is being delivered. I have to have 400 CFM of air coming across the cooling coil at a certain speed per ton of air conditioning to make everything work correctly. And we'll continue on from there in the next lesson.